Hello everyone. In this video, I'm going to discuss the derivatives of logarithmic functions. So the derivative of ln u is, with respect to x, it would be 1 over u du over dx. So we use du over dx because of the chain rule, because u is a function of x here. But if you just simply have the derivative of ln x with respect to x, so that would be 1 over x, and then dx over dx would be just 1. So derivative of ln x is 1 over x. So what if our ln, we don't have ln function, instead of ln you have log to some other base. So what is derivative of, so if you have another base log a x dx, right? So what is the derivative of this thing? So then our formula is, so derivative of log to the base a, so log of x to the base a is 1 over x and then ln a. So remember, what is ln x? So ln x is same as log base e x. So the base is e, but if the base is a, some other number, then we have 1 over x ln of a. All right, so let's do some problems and we're going to use the formulas there. Let's say we want to do this example. So y is ln of x times square root of 2x minus 3 over cube root of 4x plus 1. So we need to find the first derivative of this. So this looks like a really complicated problem because here you have u times v. So you have two terms, product of two terms on the top, and then again we have something in the denominator. So all the log problems are usually, they can become easier if you use the laws of logs. So if you don't remember the law of logs, I can just remind you quickly. So in your pre-calculus, you might have studied that. So if you have input as product inside the ln, so this can be written as sum of two ln functions, so ln m plus ln n. Similarly, if you have two functions in division, so m over n, so it can be written as subtraction, so ln m minus ln n. And also if you have something raised to power, so m raised to power n, so this is the power rule, so you can bring the power in front and you can write this as n ln m. So these are our rules of log functions that we're going to use in our problems to make them simplified ones. So now let's take a look at this one. So ln of all this. So first I'm going to rewrite my function as, so applying the rules of log, so I can write, so y is equal to, so ln of, so first I'm going to use a rule number 2, which is our quotient rule. So x square root of 2x minus 3 minus ln of cube root of 4x plus 1. And now again for this part we can use our rule number 1. So ln of product is sum of the ln, so ln of 2x minus 3 minus ln of cube root of 4x plus 1. And so again in the next step I'm going to just rewrite this as ln x plus ln of, so power form would be 2x minus 3 raised to power half minus ln of 4x plus 1 raised to power 1/3. And now, so okay, let's simplify it a bit further. So ln x, so using the third rule, which is our power rule, so you can bring the power in front and write the ln, so minus 1/3 of ln of 4x plus 1. So now is a good time to take the derivative. So what we did so far is just algebraic manipulation, so using the rules of logs. Now take the derivative on both sides with respect to x. So derivative of y would be dy over dx, which is what we are trying to calculate. So derivative of ln x is 1 over x plus half, as it is derivative of ln of 2x minus 3. So derivative of ln means 1 over 2x minus 3, and by chain rule, since this is a different expression, so we need to take the derivative of 2x minus 3, which is just 2, and then again minus 1/3. So derivative of ln means 1 over 4x plus 1, and by chain rule take the derivative of inside, so derivative of 4x plus 1 is just 4. So overall we notice that 2 and 2 cancels, and we are left with derivative is 1 over x plus 1 over 2x minus 3 minus 4 over 3, 4x plus 1. So this is our desired solution. Let's try another one. So if y is equal to ln sine x raised to power 4, find dy over dx. So in this case, so taking derivative on both sides, so dy over dx is, so dy over dx of ln of sine x raised to power 4. So first, so derivative of ln is 1 over whatever the expression inside the log. And then by chain rule, we also need to take the derivative of inside. So this was inside. So 1 over sine x raised to power 4. So derivative of sine x raised to power 4 is cosine x raised to power 4. And by chain rule, you also need to take the derivative of x4, which is 4x cubed. So we get, so 4x cubed cosine x raised to power 4 over sine x raised to power 4, and or you can write this as 4x cubed, and cosine over sine is cotangent x raised to power 4. So this is our desired result. Let's take a look at this word problem. So take a moment, pause this video and read the problem carefully. So we are given an isothermal expansion from volume V0 to V. The entropy change S can be calculated using the equation. So S is equal to N times R times ln V over V0. So we are given the value of V0, value of N, value of R, and we need to find ds over dv. So since you're finding ds over dv, it means the only thing that is variable here is v. Rest all are constants. So these are all constants and only variable is v. So when we take the derivative, so N and R are constant as it is. So derivative of ln of, so derivative with respect to V of ln of V over V naught. All right, so when we take the derivative, so we notice that, so NR as it is, so derivative of ln of V over V naught, it means 1 over whatever the argument of the ln is, so that is V over V naught. And by chain rule, so you need to also take the derivative of V over V naught. So we get ds over dv n times r, and this can be written as v naught over v, and derivative of v over v naught is 1 over v naught. So v naught cancels, and we are left with nr over v. So ds over dv is equal to nr over v. But we want when v is 3.5 liters. So just plug in the values. So what we want is, so this is our S prime. So we want the value when V is 3.5 liters. So plug in the value. So N is 0.10, R is 8.314, and V is 3.5. So overall we get 0.2375. So this is our desired answer. So this is what we were trying to find out. So value of ds over dv when v is 3.5 liters. All right, so let's take a look at the next example. So in the next one, we need to find the concavity of the function y square ln x. So we are given this function y is equal to x square ln x. So concavity when x equals to 2.0. So it means we need to figure out, is the function concave up or concave down at x equals to 2. So in order to figure that out, so what we're going to do is we're going to look at the sign of second derivative of this function at x equals to 2. And if the second derivative is negative, so it means the function is concave down. If the second derivative is positive, it means the function is concave up. So that's the plan. So let's start with taking our derivative. So here we're gonna use product rule because this is our u, this is our v. So we're gonna use our product rule. And if you haven't done it before, so you should look at the product rule video where we sing a song. 1d2 plus 2d1, product rule is so much fun. So x squared as it is, derivative of ln x is 1 over x, plus 1 over, so ln x as it is, derivative of x squared is 2x. So we get, so x squared over x, just one x is left. So we get x plus 2x ln x. But since we are interested in the second derivative, so let's take the derivative again. So take the derivative again. So we get second derivative is equal to, so derivative of x is 1. So again for this one, 2x times ln x, again we're going to use our product rule. So 2x as it is, derivative of ln x is 1 over x, plus ln x as it is, derivative of 2x is 2. So we get second derivative equals to 1 plus 2, so x and x cancels, plus 2 ln x. But we want to figure out the sign of derivative at 2.0. So value of derivative at x equals to 2 is equal to 1 plus 2 plus 2 ln 2. So basically it's 3 plus 2 ln 2, and which is 4.4, which is positive. So second derivative is positive at x equals to 2. It means the curve is concave up. The graph is concave up. So the graph is concave up at x equals to 2. So that's what we were looking for. What is the behavior of concavity? I hope that makes sense. And please watch the next video if you are interested in finding the derivatives of exponential functions. Thanks for watching.